The QUAID megaslope has 5 stages, each with 3 controls: level, time and slope. This simple but effective control set allows for the creation of complicated voltage curves with much less effort and more musicality than button-based interfaces of the past. Let's start by looking at QUAID as an envelope. A keyboard off-screen is patched to the trigger input, and the QUAID's unipolar output goes on to control both the cutoff frequency and VCA level of our synth voice. In this case, it's the SIG Guts Intertangle Quartet. To start, let's bring up the level of stage 1. A very short blip of voltage occurs. Once we dial in more time, we start to hear an attack phase. You may expect a decay phase, but that would actually require us to set the time as stage 2. This is because the time controls set the time it takes to reach the level of their associated stage. If only the first stage has a maximum level and a little bit of time, this lone attack envelope occurs. This time control goes from 1 millisecond up to 3 minutes at maximum level. If the first stage takes no time to reach full level and the second stage has a minimum level set, the stage 2 time control becomes decay time for a basic envelope. The slope control adjusts the decay stage's curve from linear in the centre up to logarithmic and exponential when all the way down. This, of course, affects the perceived time of the stage as well. Now we will bring back the longer attack time by simply turning up the first stage's time control. Now, if we switch to the gate input, the stages follow the incoming pulse width. The sustain stage selector now comes into play. Let's create a standard ADSR. The decay and sustain phases actually share a stage due to the separated time and level controls. Stage 2's time acts like the decay and its level like the sustain controls of a normal 4-knob ADSR. Stage 3 is like a release as long as its level and all following stages are all the way down. Notice how stage 2 will continue as long as we hold a key and stage 3 begins on the release of that key. Although it can be helpful to define envelopes in stage quantity and type, a more musical approach can be to simply dial in these settings as the envelope is gated. Approaching these more complex envelopes within the bounds of the ADSR can possibly hinder your creativity. It can be easier to think of each stage's level as a destination and the time controls as lines connecting those dots. Now, let's add a rise up to the final level set by stage 5. One feature of the QUAID megaslope that is very unique is its ability to loop multiple stages during a sustained gate. To activate this function, select the final stage in the loop with the sustain button, then hold the button down. The lights will come on one at a time for each prior stage, adding it to the loop selection. Here we have a loop spanning from stage 2 to stage 4. As long as the input gate is sustained, stage 2 will re-trigger at the end of stage 4. Once we release the gate, stage 5 begins. When looping stages within an envelope, it is essential to have real-time controls due to the immediate adjustment it typically demands. The time controls make it easy to get the loop playing well with other rhythmic elements. We can change the selection by pushing sustain to choose another single stage and hold the button again to select prior stages. It does not matter where you start and end, and all stages can be selected to loop during a sustained gate. This is an alternative way to access the dedicated loop mode, as the gate input will essentially act as an on-off switch for a 5-stage LFO. Notice that the looping portion can reach into audio rate, making this sustain mode even more exciting. It works great to drop little bits of FM into the middle of your envelopes. If the gate is patched to the trigger input, the sustained loop will not occur, but of course both inputs may be used simultaneously. The CV inputs over time and level work great in any of the looping modes of the QUAID. Here is a basic triangle LFO from the pip slope controlling the time of stage 2. To exit the sustain loop, simply push the sustain button to reselect a single stage. The output that we have been using is unipolar, but we also have a simultaneous bipolar out. Let's patch that to the pulse width modulation of the SIG Guts Deluxe. There are also two trigger outputs available for interfacing the QUAID further with your system. The first is EOS, which stands for end of stage. This output fires a trigger at the end of each of the 5 stages. Here we will patch EOS to trigger the attack decay envelope of the pip slope. Notice that the pip slope fires multiple times during the QUAID cycle. Technically it happens 5 times, but the perception of its triggering varies depending on the settings of both envelopes. Let's patch the pip slope to the volts per octave input of the SIG Guts Deluxe. That is fun, but we have 2 QUAID megaslopes, so why not trigger the second one from the EOS output? Let's switch to the gate input and add a sustained loop on stages 2 and 3. Now we will patch the bipolar output of QUAID 1 to the wave-shaped CV on the SID guts. At this moment we start to see the power of the 2 slope outputs and 2 trigger outputs. As the patch grows and more controls are modulated around the system, a less precise, more on-the-fly method of working presents itself. There are loads of happy accidents to be found with the multi-stage complex envelopes. The other trigger output is EOC, or end of cycle. This output will fire only at the completion of the entire envelope, or at the end of stage 5. In this case, let's patch this EOC output on QUAID 2 to trigger the pip slope. This will work better with the patch due to the second QUAID firing multiple times during the cycle of the first. Let's take the AD envelope out into the SID guts filter type. From here, playing around with the many controls is very rewarding, typically resulting in unexpected but pleasant results. The next of the 3 modes is loop. In loop mode, the envelope freely cycles, re-triggering itself at the end of its final stage. Here we have the slope patched into the output level of the Akemi's castle. Let's start to bring up some stage levels. Of course, the overall speed of the loop will depend on all of the time controls. In this mode, the sustain button determines the final stage in our loop. Now that we have a nice loop, let's start to build a patch around it. First, let's clock the Pamela's new workout from the end of cycle out of Quaid. Channel 1 is set up as a 16 times random voltage. Using that to modulate the castle's pitch multiplication will result in a nice sounding pseudo sequence. Now if we set the second Quaid megaslope to loop as well, we can patch its end of cycle to the trigger input of the first. In loop mode, the trigger input acts as a reset for the cycle. Let's modulate the modulation operators level with this second cycle in Quaid. In this patch, the two Quaid megaslopes are cross-connected. Each one is patched to re-trigger the other's cycle with its end-of-cycle gate. This makes for a more interesting looping behaviour due to each cycle now depending on the timing settings of both envelopes. Both pip slopes are also being triggered from the end-of-stage outputs. Let's alter the patch a bit by adding some rhythm. Once a pleasant loop is established, we can expand on it by splitting some of the output signals to other areas of the system. In this case, the drums are being triggered by the same end-of-stage gates firing off the pip slopes. The beats may not actually be locked to a tempo, but because the loop is fairly short, a musicality emerges. Finally, let's duplicate the positive output over to the mum-mate's filter cutoff. From here, it's fun to start changing the loop times and lengths. Because so much of the patch is controlled by these loops, unpredictable things can happen. Here we're going to modify the stage level control CV inputs while keeping the loop length the same. The PAMLA's new workout is set up like an octa-chord LFO, with each output generating a sine wave 45 degrees out of phase from one another. Changing the global tempo of PAM will slow down all 8 LFOs and impact how the loop is perceived. Finally, we can add an envelope triggered by the end of stage gates to control the DCA of the fizzle guts. The last of the 3 modes is step mode. You guessed it, a step sequencer. It can be set from 1 to 5 steps in length with the sustain loop point button, and it includes per step slides. This patch benefits from having 2 Quaid megaslopes working together. Here we are clocking the first from PAM and the second from the end of cycle output of the first. This causes the second Quaid to step forward at the start of every 5-step cycle. As they are mixed together, we effectively multiply our sequence length. We can think of the second Quaid as a transposition sequencer in this case. Playing with the transposition levels as well as the amount of steps greatly alters the sequence. Here is a variation on our original transposition sequencer idea. In this patch, we are modifying the level of a single step with the second QUAID megaslope, again triggered by the end of cycle output. We can make it a little more interesting by adding some more level modulation, this time from the Pamela's new workout. Patching another output to stage 1, we can see that this unconventional method of sequencing takes us to places we might never find with a normal sequencer. Here we have expanded on the sequence by adding drums and a fake sidechain effect on the reverb returns VCA. We are also sequencing the master filter cutoff with the second QUAID. Here's a little filter FM from the castle. Here we have separate sequencers for left and right. The CV outs are patched to the operator multipliers and the end of stage outputs are triggering envelopes patched to the operator levels. In step mode, the time controls behave like slides per step. Due to the multiplier being a quantized control, we get a nice little arpeggiator effect when we bring in these slides. Expanding the patch, we have added the bipolar sequence outputs to control the other two operator levels. Now let's take the end of cycle gate controls into the volts per octave ins of the castle to act as little percussive clicks. When used in step mode, the QUAID really demands modulation. Immediately, sequences appear to be much longer and more complex. Here is an LFO from Pam controlling a step's level. Let's add another LFO to the second sequencer. Now let's mold the second sequence into the feedback of oscillator A. Adding slides works great when modulating operator levels due to the tone shaping power of those controls, and cycling through algorithms causes big changes as the timbral control of the sequencers is essentially rerouted. We can also patch resets to the sequencer gate inputs, which will bring the sequences back to stage 1. Let's explore a few more patches using various concepts introduced throughout the earlier sections. This patch is based around the first Quaid megaslope cycling with its end of cycle output triggering the second as an envelope. Additionally, the third stage's level of the cycling Quaid is modulated by a cycling pip slope. In this patch, the Quaid is cycling at audio rate and modulating the cutoff frequency of the mum mate. PAM is controlling the stage levels and the second quaid is changing the time of stage 5. The result of this is a controllable vowel type sound. This patch looks at sequence mode again with additional drums from the Squid sample. If it wasn't apparent earlier, sequencing with a pair of quaid megaslopes can be very expressive and performative. Thanks for watching this in-depth look at the Quaid megaslope.